Hello everyone. In this video, I will present the design and architecture of my project, the Scalable notification system. In the demo video, I showed the system working end-to-end with real email and SMS delivery. In this presentation, I will explain the problem I am solving, the architecture I designed, the technologies I've used, and the key features that make the system scalable and production-oriented. So thank you for being here today. My project is a scalable notification system. It is a microservice based multi channel notification platform that I designed and built to handle high throughput notification delivery across email and SMS channels reliably and efficiently. So this project is not just about sending messages. It is about building a system that can process notification asynchronously, support multiple delivery channel, prioritize critical notifications, prevent duplicates, scale under heavy load. So in this presentation, I will explain the problem, the architecture, the technology stack, the core features, and possible future enhancements. So let's come to second slide, that is um, mm, problem statement. So modern applications depend heavily on notifications. Users expect instant alerts for password resets, login attempts, order confirmations, and account updates. They also expect these notifications across multiple channels such as email and SMS. However, building such a system introduces several challenges. The first is multi-channel complexity, second is high throughput without blocking, third is priority handling, fourth is duplicate prevention, fifth is user preferences, sixth is independent scaling, and my project is designed to solve all of these challenges. So let's come to our system architecture overview. Okay, so this diagram shows the overall architecture of my system. The client sends a request to the notification services, which is the entry point. The notification service validates the request, checks for duplicates, and publishes the message to Kafka based on its priority. Kafka acts as the backbone of the architecture and ensures reliable asynchronous communication. Priority process then consumes the notification, checks user preferences, prepares the channel specific request. Next, the message is routed to the appropriate channel topic, if it's email or SMS, sends via providers. Uh, and then finally the email consumer sends it through SendGrid, and the SMS consumer send it through Twilio. Supporting services like include MySQL for persistent storage and Redis for caching and rate limiting. The event driven design makes the system modular, fault tolerant, and scalable. So next slide is technology stacks. So for the backend, I used Spring Boot 3.4 with Java 17. For messaging and asynchronous event streaming, I used Apache Kafka with three priority topics, priority 1, 2, and 3, partitioned by priority key. And then for the database, I have used MySQL database, and therefore caching, I'm using Redis and API response caching. For external notification delivery, I integrated SendGrid for email and Twilio for SMS. For environment setup and service orchestration, I've used Docker Compose, and this stack allow me to build a system that reflects the real production architecture rather than a simple prototype. So let's our so core features of this project are this includes single notification API for all incoming requests. It supports multiple channels, currently email and SMS. It uses priority based queuing so that critical messages can be processed before informational or promotional traffic. It supports user preferences to control what users receive. It includes duplicate prevention using message hashing. It supports template based notification and uses Redis based rate limiting for external provider protection, and it supports horizontal scalability through stateless services and Kafka based decoupling. So in my next slide, for multi-channel notification delivery, my system currently supports two channels, email and SMS. It sets email to SendGrid. For email, I use SendGrid, which accepts requests and returns HTTP 202 when the email enters its processing pipeline. For SMS, I use Twilio, which returns a queued status when the message is accepted. Even though these are different providers, my system handles them through a consistent pattern consumed from Kafka, call the provider API, and log the result. The consistent structure makes the system easier to maintain and extend. Next is priority based queuing. So a key design feature of my project is priority based queuing. I define three priority levels. So priority 1 is for transactional notifications such as OTPs and security alerts. Priority 2 is for informational notifications such as updates, reminders, and etc. And priority 3 is for promotional notifications such as newsletters, some campaigns, some event marketing, and etc. So each priority level has its own Kafka topic and dedicated processor microservices for independent scalings. This is especially important in high load scenarios where promotional traffic can spike significantly. So next is how Kafka event streaming is working. So the Kafka is the communication backbone of my system. The notification service publishes incoming requests to Kafka topics through a priority processor, consumes those messages, applies business logic, and republishes them to channel specific topics. Then the email and SMS consumers deliver the notifications. And then Kafka provides persistence, scalability, and fault tolerance. If any consumer goes down, messages remain stored in Kafka until the consumer recovers. So this is one of the main reasons the architecture is important. And then let's come to our next slide, which is user preferences and duplicate prevention. I built two practical enterprise style features into the system. One is user preferences and the other is duplicate preventions. For user preferences, I store rules that determine which notifications are allowed on which channels. These preferences are cached in Redis for fast access. And for duplicate prevention, I generate a SHA-256 hash using user ID, channel, and message content. This hash is stored with a unique constraint in the database. So if the same request arrives again, the system detects it and returns HTTP 409 conflict instead of sending a duplicate notification. So this protects both the user experience and external provider uses. And the next slide in my presentation is database schema design with MySQL. So the user table stores user details. The notifications table stores each notification request and its unique hash message. Then preference table stores per user notification setting. Then delivery log stores table stores the result of each delivery attempt. And then template stores reusable message templates. So together this table give the system structure and integrity. And then next is API design, so RESTful notification API. So here I'm in my project I'm using Postman to post request, and I'm using it locally on 8080 port. And content type is application JSON. The request includes priority, channels, recipient details, and content. The response codes are 200 OK, so notification accepted for processing. Then 400 bad request, invalid channel or missing fields. Then if you get 409 conflict, then duplicate notification detected. And if you get 500 internal server error, so processing failure. So if your response is accepted, then you'll see notification accepted for processing. And then this is my request body where I can select the user email. I can select the channels if it's email, SMS, and in future I'm planning to introduce push or pop notifications. So yeah, and then here you can write your message or email subjects. The next slide is end-to-end notification flow. So first, client sends a request to the notification service. The notification service validates it, checks for duplicates, and publishes it to Kafka. Kafka stores the message. The priority processor consumes it, checks preferences, and route it to a correct channel topic. The email or SMS consumer calls the external provider. For email it's SendGrid, and for SMS it's Twilio. And finally the result is written to the delivery logs tables. This makes the processing asynchronous, reliable, and scalable. And then the next is microservices architecture. So my project uses microservices based architecture. The notification service acts as the API gateway. The priority processor handles prioritized business logic. Then the email consumer handles the email delivery. The SMS consumer handles the SMS delivery. So each service has a focused responsibility and can be scaled independently. So this improves maintainability and deployment flexibility. So next is scalability and rate limiting. So scalability is one of the main goals of this project. So Kafka partisans support parallel processing. The services are stateless, making horizontal scaling easier. Different components can be scaled independently depending on their workload. For rate limiting, I use Redis to track outgoing provider requests and avoid exceeding provider quotas. This helps keep the system stable under heavy traffic. So and here's my last slide for the future enhancements and the conclusion. So to conclude, my project demonstrates a scalable, event-driven, multi-channel notification system built with modern distributed systems by principles. It supports asynchronous processing, email and SMS delivery, priority-based routing, duplicate prevention, user preferences, and rate limiting. In the future, I can extend it to push notification, monitoring, dashboards, and Kubernetes deployment. That's the main upgrade I'm planning to do in future, and multi-tenant support. So overall, this project shows how a real-world notification platform can be designed for scalability, resilience, and maintainability. Thank you for your attention, and if you have any questions, I'm happy to answer any questions. You can find my project on this URL, my GitHub RN17 notification system. Here is my project where it includes notification processor priority 1, 2, 3, email consumer, SMS consumer, different this microservices. I've included my readme file, so you can find all the features, architecture, prerequisites, and how you can clone this repository and start all microservices using. I've also included start services and end services sequence commands. And this is my GitHub repository where you can find all these project details and all the required file to run this project. So thank you for watching this video.